Hello, good morning, good evening, everyone. We are going to do Advent of Code 2025 in Wolfram language 2025 Advent of Code Day 3, Problem 1. If you are here, say hi. Love to see your comments. If you are not here, play at 1.5 speed minimum. Okay, so let's just start coding. Okay, Wolfram language, if you don't know yet, I have done hundreds of videos in the past of introduction and download, where to download, and complete tutorial. Just search for it, XRL Wolfram language for programmers. You can see complete tutorial from the ground up. Okay, and that's Wolfram language is a magnitude more high level than all existing programming languages. Okay, so let's begin. Advent of Code number day 3. So we go back to this Advent of Code idiotic thing and start Wolfram language. Let's see. We'll code for an hour maybe, and let's see how far we can go or we can finish it. I'm a slow coder. As I code, I talk, I tell you my analysis about whatever things. Okay, so new notebook, 3 shift enter to evaluate it and start the kernel, and let's magnify. Okay, so we got 3. So let's see. So far so good. Video check, audio check. Okay, say hi. Okay, so you descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They are all offline. Sorry about that, an elf apologizes as she tinkers with a nearby control panel. Oh, it's a she. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if the escalators weren't also offline. Okay, so they are what is this? The elevators and escalators, okay? But don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators, okay? I'm confused, I don't know what he's talking about. Ching ACP. Happy holidays. Thank you, ACP. This is my yearly donation. Fantastic. Fantastic, ACP. So far, I read the story, but I didn't pay attention. But let's see. There are batteries nearby that can supply emergency power to the escalator for just such a occasion. The batteries are each labeled with their voltage rating. A value from 1 to 9, you make a note of their voltage rating, your puzzle input, for example. So we got 4 numbers, okay? So that's the input, 4 numbers. The batteries are arranged into banks. Each line of digit in your input corresponds to a single bank of batteries, okay? Each line of digits. Okay, so you got 4 numbers. Each one is a bank. Within each bank, you need to turn on exactly 2 batteries. Okay, the voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, the bank would produce 24 joules, okay? 2 and 4. Okay, so you cannot rearrange batteries, okay? So each sequence, each number you are given 4 numbers. Each number, there are many digits. And apparently you can manipulate each digit. each digit represent a battery. Within each bank, you need to turn on exactly 2 batteries, okay? So you need to pick 2 digits in this number. And once you picked them, you combine those 2 digits. That forms a new number, in this case 24. And that's it. That is the jolts, okay, for this given sequence of digits, okay? You need to find the largest possible joltage each bank can produce in the above example. Okay, this seems looks like I understand already. So given this number 98765 something something, you can make the largest joltage possible, 98, by turning on the first 2 batteries. Okay, so you just pick the first 2 digits, 98. Then that forms the number 98. That is a joltage that's the largest possible. So basically, you want to pick the first you want to pick number close to 9. Okay, let's see. You can have 91. Let's see what's a priority. Okay, you can have 91, 99. Maybe not. That's not available. You also can have, let's say you have 1, 5. Well, I don't know yet. Okay, pick 2 numbers. Now in this 81111 something 9, you can make the largest joltage possible by turning the batteries labeled 8 and 9. Okay, producing 89 jolts. Okay, 8 and 9. So let's see, how many digits are there? Copy. Back to Emacs. Paste. Select 15 characters. Wait, so this is not what? 1, 2, 3, 4, 5, 6, 7, 8. Wait, how does that actually count? You got 15 digits there, okay? So then in this number, you pick 7, 8. Okay, then in this number, you pick largest joltage is 92. You pick, okay, so here is a tricky part, 92, okay? The total output joltage is the sum of the maximum joltage from each bank. So in this example, the total output joltage is 98 plus 89 plus 78, 92 equals to 357. Okay, there are many batteries in front of you. Find the maximum joltage possible from each bank. What is the total output? So you just pick 2 digits out of them. Their position doesn't matter, just like pick 2 digits, okay? So you just pick 2 digits. So let's begin to do this problem. Okay, Wolfram language code. So what is the problem? So make them a comma. Okay. Then input, you got these 4 numbers, okay? So let's say this example, you pick 2 numbers. So 81, what about 88? Oh, you can also have 89. So you need to pick 2 numbers. So there is interplay. So the first biggest number. So you could have a well, we need to figure out the algorithm. So you could have 9. So first step, you find the biggest number. So that's 9. The second step is you find a number that's after. You pick a digit after the digit you picked. So in this case, 9, 1, if you go by this algorithm. So 9 is the biggest. Then second biggest, then the biggest after 9 would be 2. So this would be 9, 2. Okay, so it's actually correct. Oh, so there's no big deal. You just pick the biggest digit first. Then you pick another digit after that digit. Okay, now complication. What if you have a number, let's say 9, let's say A9, let's say 2A9, okay? You pick the biggest one, that's 9, but there's no more digit to pick, so you can't pick 9. So first step, okay, so let's write it out. Steps. First, pick the largest. Okay, largest digit in the number, but not the last one. Okay, you cannot pick the last one. Then pick the largest digit after the digit you picked. From the digits that is after the digit you picked. Okay, so that is the algorithm. Looks like that's it. Is that it? If that's it, it's pretty simple. But are there special cases? What if there's 0? Okay, I don't. Anyway, yeah, it looks like that's the algorithm. Okay, let's work on it. So, given a number, hold on a second, I gotta go. I'll be right back. Hello guys, I'm back. Hello guys, I'm back. That's a long delay. So what happened is that I'm going to stop this video, so we need to do this again, okay? Yeah, so that was a 30 minutes delay or something. So let's do this another day. Thank you guys for being here. Bye guys.